Now for number 45, this is a little bit tricky because you have to really identify what kind of an equation you have. So if you have an equation like this where there's a log, and a number, that means you have to get all the logs on one side and the numbers on the other side. If we had just log and log, then we would just set the arguments equal to each other, just like that. But since this number is in there, we really can't do anything unless we get the logs on both sides. Sorry, scratch that. Unless we get both logs on the same side. So getting both logs on the same side means that we're going to go ahead and subtract the log base 10 of x minus 2. So we're subtracting that expression from both sides, which means on the right side we no longer have a log expression. On the left side we have two log expressions. The log of one argument minus the log of another. But we know, I'll go ahead and rewrite that, log of 7x plus 1, I was going to say, we know that we can use the quotient rule there, but I'll rewrite that so we know where we're at here. Now we have the difference of logs, so we can rewrite that expression as the log of a quotient. And the log of a quotient now is equal to a number. So we have a log on one side, number on the other. Our variable is locked up in the argument, and so we've got it locked up in our argument. So we have to convert to exponential form. We know, again, when we don't see a base, that we know the base is 10. So we have the base raised to the answer, or the exponent is the log is the exponent, so that's the exponent. 10 to the first power, you got to get from here to there to there. So 10 to the first power equals this expression. When we get to this expression, again, we have another rational equation. We want to get rid of the fractions. To get rid of the fractions, we're going to multiply both sides by x minus 2. And then we have 10 times x minus 2. If we distribute the 10 to both terms, we're going to get 10x minus 20 equals 7x plus 1. So just by doing the basic things, so understanding that the logs have to get to one side, combining the logs using the properties, and then converting to exponential form. Now we have a very simple equation that we should be able to solve by subtracting 7x from both sides. And at the same time we do that, let's go ahead and add 20 to both sides, because now we just have a linear equation. And a linear equation, we just let's get the x by itself. And getting the x by itself, we move the numbers to the right side and move the variables to the left side. On the left side we get 3x. On the right side we get 21. Dividing both sides by 3, we get x equals 7. Again, we always have to check to make sure that that number, we can put it back into the original equation, and it makes sure, we've got to make sure that that number doesn't make an argument 0 or negative. If we put a 7 in for x, we get 7 times 7 is 49 plus 1 is 50. That argument checks out. So 7, we're allowed to plug 7 in for that. Over here, 7 minus 2, well, that's a positive number as well, so we're allowed to plug 7 back in. So we have to make sure we always check.